So when we're in the viewer manual tracking controls mode, we create all trackers manually one by one carefully. In the viewer, right-click zooms in and out, middle-click pans around the image. Left-click does nothing unless a tracker is selected. Because if a tracker is selected in the point browser and you left-click in the viewer, the tracker will jump to where you clicked, which is very inconvenient. So don't absent-mindedly left-click if a tracker is selected. Let's begin by enabling image correction by pressing I or through Windows, Image Control window. Boom. Okay, we zoom in on the area where we want to place a tracker and find a high contrast spot. Naturally, before starting any tracking, we analyze the shot and look for areas that stay visible in the frame the longest. Obviously, I won't just attach a tracker to this particular spot. If we scrub forward, it quickly disappears behind the pipe. And that's not what we want. The longer a tracker stays in frame, the better. So we specifically choose those more stable areas. So let's pick this spot, for example. While holding Control, click the left mouse button. This creates a new tracker. It appears in the point browser. Here it is. Let's go over its settings. It's important to understand how the parameters are logically divided into groups. The point block contains general tracker settings. The 2D tracking block handles everything related to 2D tracking. The 3D calculation block affects how the 3D position of this point is calculated. You should keep in mind that this isn't just a random list of parameters. If your 2D track looks good, but something's off in 3D, you don't need to touch the 2D settings again. The problem lies elsewhere. Identify the name of the tracker. Right now it's called 3255 because we've run the auto tracker several times and it has created a lot of points. When doing manual tracking, you usually know each point by name. Sometimes it helps to rename them manually, for example, sign, ground, car. This makes grouping and navigating much easier. Color. This is the color of the tracker in the viewer. If the image is low contrast, pick a brighter color to help spot the point. Default is red. 3D point color. This is the color of the 3D cross in the lineup browser. Default is green. All these visuals can be toggled on or off. Tracking mode. This is the key setting that determines how the point is tracked. 3DEqualizer is particularly powerful here. It offers many advanced modes. One of the most basic and widely used ones is pattern mode. What does pattern mode mean? You have a pattern, a template, and a search area. From frame to frame, the software looks for this pattern within the defined area. The size of the pattern and search area should match the camera's motion. If the camera movement is strong, increase the search area. If the motion is slow or subtle, you can reduce it. Tracking will be faster. For example, if we place a tracker in a stable area and hit track, we'll see it track smoothly to the end of the shot. But if we place it on the sign and leave the same search area, the track might fail because the image shifts too much and the point flies outside the search zone. That's exactly what just happened. It couldn't keep tracking because the motion exceeded the search boundary. Let's create a tracker. I'll increase the pattern size, extending it more to the left and right since that's the direction the camera is moving. Click track and the tracker runs until the motion becomes too strong. At that point, tracking stops. That's an error and we'll fix it now. I'll delete the tracker. How do you check whether your tracking is good? Any kind of tracking, 2D or 3D, is best verified through image stabilization. When the image is stabilized, you can immediately see what's holding steady and what's sliding. In this case, the track breaks because there's parallax inside the pattern details within the pattern shift relative to each other. Ideally, everything inside the pattern should remain as stable as possible. Let's reduce the pattern size, maybe keep it vertically elongated, that's totally fine. Increase the search area, so it still covers the motion range. To better monitor the tracking, enable 2D tracker centering. This pins the tracked point to the center of the frame. Click track. And we've tracked this tracker all the way to the end, even a bit beyond, and it stays stable throughout the entire required range. This is the last frame where our tracker performs well. Here we click endpoint. This will be the final frame of the track. After that, the point is no longer used. Okay. Alright, what about the first tracker? It's rather short, but let's leave it. We'll also finish it here. Click endpoint, and that's where it ends. Now, what other types of trackers are there that don't exist in other programs? What's referred to as a marker. It's a distinct, high-contrast visual element. When we create a marker tracking point, we slightly reduce the tracking area. Then the marker must be calibrated. click Gauge Marker, and the software will automatically detect the exact feature we want to track. Important, you shouldn't select too large of an area, or the tracker might fail and jump onto another object. For example, it could accidentally jump to a neighboring detail. Calibration can also be triggered using the hotkey X. The search area is the zone where the software looks for the tracker between frames. The more movement there is, the larger this area needs to be. Click Track. Endpoint ends the track. You can click it manually or press the E key. The pattern type tracks the entire selected area. It looks for a full match of the pattern from frame to frame. The marker type focuses only on the high contrast central part within the selected area, ignoring everything else. This is useful when tracking distinct, well-defined elements. Alright, what else could we demonstrate it on? For example, here's a marker. Make sure to calibrate it several times to ensure it doesn't drift, and the software recognizes it correctly, then press Track. Right, once it starts drifting, that's no longer acceptable. This is just an example of how the marker tracking mode works. Just so you know, if a marker drifts like that, it's already a bad sign. There's also a tracking mode called Corner Edge. It detects corners. We select a distinct high contrast corner and click Gauge Marker. And click Track. This is useful when it's hard to track with pattern mode. For example, when the corner is clearly visible but everything else around it is unstable. In such cases, corner edge tracking works well. Edge corner is best used when there's nothing else to latch onto, but it does work. For example, we can try tracking this corner. Because for the pattern mode, it's bad if we try to track this part. It changes and everything behind it parallaxes. But for edge corner, that's acceptable. Calibrate using the button or press X on the keyboard and track. Use the track button or press T. You can use the left and right arrow keys on the keyboard to move between frames. Press E to set the end frame of the track or use the endpoint button. Let's move on. So, let's say we position ourselves not at the beginning or the end, but somewhere in the middle. For tracking, it's better to choose a frame where the object is still sharp, without motion blur. For example, starting the track from this frame is better than from the one where the sign is already blurred. To demonstrate the functionality, I'll start from the middle. Hold Ctrl and left click to create a tracker, then move on. Direction determines the tracking direction, forward, backward, or both. If set to forward, the track will proceed from the current frame forward along the timeline. This is shown by the purple bar. It indicates the tracking range. Click Track, and the tracker starts moving forward. To track backward, return to the frame where you started and switch direction to backward only. However, the purple area on the timeline might not appear. In that case, check the tracker's status. It's shown next to the point in the viewer as a small label. If it says the tracker is active and visible, you can press Track and it will track in the backward direction. End frame. Tracked. Start frame. It indicates the current status of the tracker at the given frame. And then it all becomes more or less clear. If we're at the very end and the direction is set to backward, then this becomes the start frame, the first point, because we're tracking from the end of the shot toward the beginning. The leftmost point will be marked as end frame, as if the track is already finished, even though we've just started tracking from it. If we switch the direction to forward, it immediately becomes the start frame, and the last one turns into the end frame. When tracking in the opposite direction, for example, backward, we select backward only, check the status of the end frame, and switch it to start frame. To do this, press endpoint and the purple tracking zone expands to the left. Then press Track. And then the tracker disappears from the frame, so we press endpoint again to close it. That's how reverse tracking is done. It's not the most convenient or intuitive process, especially if you've just started working with the software, but now you know how to track in both directions. And also, when the backward and forward direction is used. For example, we want to track this object. It's better to place the tracker not in the center of an area, but for example on a corner, a clearly defined point. This becomes especially important when the tracker moves significantly through the scene and is later viewed from a different angle. In such cases, it's hard to consistently hit the exact center of a smudge or marker. But a corner is easy to find because it's a junction, and it always stays in the same place, unlike the center, which can shift. So, a good rule of thumb is to find such anchor points that remain stable regardless of the camera angle. A junction or corner is an ideal option. A corner or a very small detail works best because a large point can blur or deform. The forward and backward direction means that you define a starting frame and the program tracks in both directions from there, continuing as long as tracking remains possible. You set this point to stop the tracking, I'll press endpoint. Tracking in both directions means it will track from the starting point to the endpoint, connecting the motion trajectory between them. I press track. It tracked forward and backward. And it didn't just track, it specifically aligned the path to the keyframe where we placed that tracker. I'll show this in a more visual way, though it's less technically correct. For example, if we place the first point here and the second point where we want the tracker to end up, for instance, here, this is incorrect, but we'll see how it works. Press endpoint. I select the tracking direction and press track. And it doesn't just track through the area, it actually adjusts the motion path to align with the endpoint. This is useful when a tracker drifts in one direction when there's a consistent offset. Naturally, I'll delete this tracker. Next, RGB weight. If your plate has noise in one of the channels, or if the image blends in some channels while staying more contrasted in others, you can adjust the brightness weight of each channel. For example, if the blue channel is very noisy and loses detail, you can set its weight to 0, so the tracker ignores it. Same goes for the other channels. This setting controls how much the brightness of each channel. Next is blur. The blur area isn't shown by default, but 3DEqualizer internally applies a slight blur to the image during tracking. By default, it's a 5x5 pixel blur. You don't see it, but it's applied. If your source footage is very high quality, you can disable the blur. But in most cases, tracking works better with it enabled. If the material is more specific and the blur might negatively affect tracking, keep in mind what this parameter actually controls. Deep tracking is a mode used for tracking based on reference photographs. We'll come back to it a bit later. Compensate luminance changes, same as in auto tracking. If the image brightness shifts slightly, this option allows the tracker to adapt. In general, it rarely causes problems and is enabled by default, which is a good thing. However, if brightness changes drastically, you'll still need to track frame by frame manually. The next tracker parameter is reference pattern. There are several options: previous frame, previous keyframe, first keyframe, and explicit frame. The reference pattern is the very pattern used as a baseline when moving from frame to frame during tracking. It's the one the image is compared to at every step. Below that are the frame-by-frame tracking buttons. When the previous keyframe option is selected, each time we track the next frame, the software uses the pattern from the previous keyframe. This is shown as a darker purple area. This mode is useful when the tracked pattern doesn't change much over time. However, if the pattern gradually changes in the shot, the previous frame mode works better. In this case, at every tracking step, the software uses the previous frame, not the keyframe, as the reference. So the tracking happens frame by frame. What's the difference? If previous keyframe is selected and the pattern changes slightly over time, eventually the software will stop tracking and say it can't find the pattern anymore. You'll need to set a new keyframe. If previous frame is selected, smooth changes won't stop the tracking, since each time it uses the pattern from the previous frame, allowing the tracking to continue without interruption. You can also set the reference pattern to be the first keyframe, depending on the tracking direction. If you're tracking forward, the first keyframe is on the left. If you're tracking backward, it's the rightmost frame. You can also manually select a specific frame to use as the reference. There are ways to edit 2D trackers. One of them is the Edit 2D Tracks tool. When a tracker is selected, click it to manually adjust the graph of the 2D point, its X and Y positions. You'll immediately see where any jumps or irregularities occur. Right-click, zoom in and out of the graph. Middle-click, pan around the view. Alt and left-click, select keyframes. Here we can either delete that section of the track or select the drifting tracker and press Align to Key. This tells the program to find the pattern from the previous keyframe in the current frame. But for this to work, we first need to help a bit. Manually place the tracker roughly back where it should be. And the program reverted to the previous keyframe. And found the same pattern in the next frame. After we've changed the position of the tracker somewhere in the middle of the track, here's the start, here's the end, and we adjusted the point in the middle, it's important to pay attention to the status line. If it says the status is tracked. After we made changes in the middle of the track, everything that comes after that point is marked as obsolete. This means we need to retrack the remaining part. The status is now tracked again. Next parameter I'll demonstrate by placing a track on the truck simply because it seems like its perspective changes more than that of the ground surface. I set the track, and here are the parameters: rotate reference pattern and scale reference pattern. What do they mean? This means that as the tracking progresses, the surface plane rotates and changes in size, and the tracker's pattern will adjust accordingly, meaning it will rotate and scale in perspective. Here's how it looks. Now when I press it, we'll see a white field. This will show how the reference pattern changes in each subsequent frame. This is only visible during tracking. Equalizer tracks quite fast, and there's a button to slow it down, as funny as it may sound. The fast-slow toggle exists solely to make Equalizer track slower. Why? Just so you have the chance to observe things in time, catch them, and stop the process if needed. Equalizer is a pretty fast program. Let's take another look. We place the tracker, and here the pattern starts changing. But due to the snow, the tracking breaks off, and by the end, it gets lost. This is exactly the perspective change and rotation of the reference pattern we were tracking from. Now let's try turning off these options. I'll slightly rotate and move the pattern. We can immediately see that the tracking is much worse because we essentially told it that the pattern doesn't change in size or rotation, which is not true. So, in each subsequent frame, it's trying to find this exact pattern, and without accounting for those changes, it's much harder to track. But of course, there are plenty of cases where this actually helps tracking. Just keep in mind that these options exist. If the perspective and scale adjustments are making tracking worse, disable them, and the track will proceed more steadily. The next options probably aren't as relevant. These are for automatic keyframe placement during tracking. By default, keyframes aren't created, but if you enable this option, keyframes will be placed during the tracking process. The dark colored keys, those are the keyframes. By the way, thanks to the fact that keyframes are being placed and tracking happens relative to the previous keyframe, we see that in this section, keyframes appear more frequently. So starting from here, the next frame is tracked relative to this keyframe. Then another keyframe is added, and tracking continues relative to that one. But even though the trajectory may look smooth, it's still a poor tracker. We can clearly see that by the end, it drifts quite a lot. This is exactly one of those situations where the forward and backward tracking option could help. We can see that the tracker gradually drifts, and with bidirectional tracking, we could have made a correction and stitched the trajectory together. It's really hard in situations like this to tell whether you place the keyframe in the right spot. To help with that, you can use the page up and page down keys to jump between keyframes. Press page up to go to the previous keyframe and page down to go to the next one. This lets you quickly switch back and forth and check if the tracker was placed where it should be. For example, I think it should be placed a bit higher. On the numeric keypad, you can use the keys 2, 4, 8 and 6. they form a cross. These keys allow you to very precisely move the tracker up, down, left, or right and compare the result. For example, I look at the previous keyframe. Switch to mine, press 8 to move it upward. Press it several times or hold it down. You can see how tiny this movement is, practically the size of a single pixel. By the way, it's an anamorphic pixel with a 2:1 aspect ratio. The sensitivity parameter is a threshold that defines when the tracking should stop, depending on how much the current pattern diverges from the reference. With low sensitivity, tracking continues even with large mismatches. With high sensitivity, it stops at even slight deviations. Stop low quality tracking is an option that stops the tracker if it can't get a good match at all. If disabled, the tracker will keep going until the end, regardless of how poor the match is. Spline tracking boxes. Okay, I'll show it now. For example, we place the tracker here and track a few frames forward. You can track frame by frame using these buttons or by pressing the B and U on the keyboard. You can also right click on any of these buttons to see additional options. Define shortcut. And here you can either set your own shortcut or check which one is currently assigned. On the keyboard, it's the period key, dot key. So we track a few frames forward. And now we want to shift the reference pattern. Let's say something might have occluded the frame here, and now we start tracking. By the way, it's very convenient that you can change the pattern's position at any moment. The main rule is that the central point should always stay in place. You can, for example, even move the pattern away from the point. We can see that the area we're tracking is now outside the pattern, and now it's connected to the pattern by a dotted line. But in some cases, you can even allow yourself to do this. The main thing is that the point stays in place, because if we start tracking a different area, it will also gradually drift away. So, spline tracking boxes. We can see that the pattern moves smoothly. If we disable this option, it won't move smoothly anymore. It will instantly snap to the new location, exactly where we moved it. By the way, a quick note. Let's create a tracker with an offset, like what we had when we disabled rotation and scale adjustment while keyframes were being added. How can we align such a tracker when there's a fairly uniform offset? Let's place the tracker in the final frame exactly where it should be. You can jump to the first and last frames using the home and end keys. Home takes you to the very first frame, end to the last one. Now I have this tracker selected. I click Edit Tracks. The graph showing the 2D tracker's position changes over X and Y appears. We can see that everything is progressing fairly smoothly. And at the end, here is the final frame. This is our correction of the tracker's position. There's a very useful function. It's available both in 2D tracker edits and in the curve editor. We select the range of keyframes between the first and the last frame. That is, we're selecting the nature of the movement. We understand that the tracker is drifting, but we want to preserve the trajectory itself. We leave the first and last frames unselected so they don't get deformed. Then we click Patch Curves. And now this trajectory is adjusted to fit the first and last keyframes, as if it's been patched between them. Let's take a look. It's still not perfect, but the drift has been compensated. To extend the track, besides adjusting the pattern's position relative to the tracked feature, we can also interrupt the tracker and restart it when something, like a passing pipe, temporarily obscures it. That way, we can track a point that gets interrupted. For example, this one. Hold Ctrl and click to place a tracker. We can see there's a high chance this tracker might be occluded by the passing object. Let's shift the pattern slightly right away. Now let's step through the frames. Here the tracker has already drifted because the pipe overlaps the pattern area. We can go back one frame. We shift the reference pattern and track one more frame. We can also move one frame forward without pressing track to check if the marker is still visible in the next frame. Next, if there's only a slight parallax, we can move the tracker to a nearby area on the same plane. The further we move it, of course, the worse it will perform. And return it to the central point area we're tracking. This way, we tracked neighboring areas while the tracker was occluded by an object. But if it's not possible to extend the tracker this way, you can interrupt it. Create a tracker and track forward up to the point where the tracked area is still visible and not occluded. Click Endpoint to stop the track. Go to the frame where this area becomes visible again. With the interrupted tracker selected, click with the left mouse button. And now it continues. You can see it if I place it over a bright background. Here's the gray area where the tracker is inactive, then the purple area where it's active, and then another purple segment where it continues. So this is the same tracker, interrupted for those 2 frames. And then we set the reference pattern and continue tracking. Why is it better to continue using the same tracker rather than creating a new one? Because during camera solving, the program tries to determine where each point is located. And when you interrupt and then continue the same tracker, it doesn't treat it as a new object that needs to be analyzed from scratch. It's seen as a continuation of already known data, still tracking the same area. This gives the software more information about the object's motion, resulting in a more accurate solve. If you create a new tracker every time, each point ends up with very little motion data, which lowers the quality of the result, so it's always better to continue the same tracker, as long as you're still tracking the same area. We interrupted the tracker and are continuing it again. To deselect the tracker, you need to make a new selection while holding Alt. As strange as it may sound, simply clicking elsewhere will immediately move the active tracker to that spot and ruin it. This is a very common and awkward mistake, especially early on when you are still getting used to the interface. The tracker is selected, you just click in the frame, and it's ruined. And yes, let's dispel the myth that tracking is a quick process. I've had shots that took me a month to track. Every tracker is literally the result of long and meticulous work, so treat them with great care. If you're absolutely sure you have a perfect tracker that doesn't need to be moved or edited, you can lock it. When you activate Lock Curve, a padlock icon appears. And no matter what you do, you won't be able to accidentally mess up that tracker. Or if there are too many trackers on the screen and they interfere with your ability to evaluate the image, you can hide the selected trackers. You can also select trackers directly in the point browser. The next block of tracker properties relates to calculating the position of the point and the camera. We'll now quickly go through all the parameters, but we'll return to some of them later, specifically when we dive into geometry and measurements. For now, let's just go through them to understand what each one does. So, that's everything related to 2D tracking, the settings that affect the actual tracking of the two-dimensional feature. Next come the options that relate solely to calculation, meaning they don't affect 2D tracking at all. These parameters are only taken into account during the 3D calculation stage, specifically when you click Calc All from scratch. That's when the settings from the 3D calculation block start being applied to each point. What do we have here? The calculation parameter defines the status of your tracker during the solve. Either it participates in the calculation or it doesn't. For example, if a tracker is a bit unreliable, you can temporarily disable it and see whether the result improves, or vice versa. You've spent a lot of time on a tracker, but after solving, the overall result got worse. That's when you experiment. Maybe it's better without that tracker. This happens. Sometimes even a well-tracked point should be disabled. Or alternatively, you might need to add a few more nearby trackers and then it will work correctly as part of the group. Or passive calculation. Triangulation only. What does that mean? It means that this tracker does not participate in solving the camera, but its 3D position is still calculated based on the already solved camera from other trackers. In other words, the program simply triangulates the point in 3D space using the known camera movement. This is something in between a fully disabled tracker and one that actively contributes to the full calculation. Also, everything we set is displayed right here in the tracker properties. Right now we see that the status active means the tracker participates in the camera solve, while the status passive means the tracker is only triangulated. The next setting is triangulation permission. Here we define whether we allow the point to be just triangulated or whether we require it to be actively used in the calculation. This can be a bit confusing, but when we run the camera solver, the algorithm itself may decide that a certain tracker is causing issues and automatically switch it to triangulation mode. If the point is important and we want to ensure it is always used in the calculation, we should select forceful point conclusion. But if we don't mind and trust the solver to decide, we leave the setting to default. Survey type is a parameter that refers to the position of the point in 3D space. We specify whether this position is known exactly, approximately, or not at all, in which case the program will calculate it automatically. Survey free means we don't know the point's position in 3D space. We have no onset information, no measurements. For example, if this were a room or another filmed location and we had coordinates either measured manually, provided by a supervisor, or extracted from photogrammetry, we could define the exact position of the point. In this case, we don't have that data. Using survey data, information about the point's position in space significantly simplifies tracking. The more input data we provide about point positions, camera parameters, etc., the more accurate and stable the solve becomes. For instance, solving a camera without survey data requires at least 6 tracked points. To solve the camera using available survey data, for example, if we know the positions of the objects we're tracking, 4 trackers are enough. If we've specified the camera movement type as constrained, meaning the camera is stationary and only rotates, just 2 trackers are sufficient. The more information we provide, the easier and more accurate the tracking process becomes. If we don't limit the search area and provide too little data, the result can deviate significantly from what's expected and from what the project actually requires. Survey free means we don't have any information about the point's position. For example, if we want to track a hill but don't know its exact location in space. Such data can come in various formats, from GPS coordinates, latitude and longitude, if it's an outdoor shoot, to photogrammetry data, scene geometry, or manual measurements from the set. Survey free, that means there's no data. Approximately survey means we have an approximate position of the point in 3D space. We can manually enter the coordinates for X, Y, and Z, as well as define the allowed margin of error, accuracy, which the software will take into account during the calculation. That is, a specified radius of 10 centimeters means that the tracker is positioned at the given coordinates in 3D space, but with a tolerance, the software will assume it can be located within a sphere of 10 centimeters radius around that point. We can say that we have exact data about the position of this point and can enter it. In this case, the accuracy radius field becomes unavailable, but we get the option to disable one of the coordinates if it's unknown. For example, I'm tracking the surface of the ground. I don't know its position along X and Z, but I can see that I'm tracking a generally flat surface. So I say, I don't know X, I don't know Z, but I do know that Y is 0. This is a convention I've chosen. The ground is at Y equals 0. I can track several points and set Y equals 0 for all of them. This way the program will know that these points lie on the same plane and will align it along the Y-axis into the XZ plane. Later, one of these points can be set as the absolute 0 point by assigning all its coordinates to 0. This is one of the ways you can help the program with calculations even without knowing the exact coordinates. We either know something, assume something, or define a convention within the shot. Of course, having precise coordinates is ideal. It doesn't get better than that. But sometimes you can make reasonable assumptions. You can even define a relative scale. If I set this point as 0 and another point, say on a hill, as 2 meters along X, 0 on Y and Z, that already provides useful information. And a third point in front could be set with Y equals 0, leaving X and Z unknown. These are conditional techniques you can use when you don't know the exact coordinates but can make logical approximations. And a small remark about setting coordinates to 0 conditionally. Obviously, the ground surface is not perfectly flat, so when we say multiple trackers lie on the same plane, they actually have some deviation. It all depends on how many such points you've defined, how close they are to each other, and how confident you are that they lie on the same plane. This affects the calculation accuracy. That's why it's important to find a balance. Do you really need to set this as a convention? Or would it be better to use other ways of orienting the scene, which we'll return to later? In any case, just know this approach is available. You can assume all points are on the ground, even if it's snow piles or uneven terrain, and use that as your starting reference. There's also a tracker type called lineup only, but we'll come back to it when we cover geometry. The infinity distant option means that the object is infinitely far away, like stars in the sky, the sun, or a very distant horizon. It represents the furthest possible point. If you assign this option to a tracker, it will be used primarily for orienting the scene during camera solving. So, when tracking something located at a very large distance, be sure to enable this setting. It tells the program that the object is truly far away. Next is the range where the tracker actually exists. We can track it until it goes off screen, and even beyond that. For example, let's take an area that goes off screen. We select a high contrast area and start tracking. Since the point moves out of frame in some cases, when there's nothing else to track, you can use this technique. Of course, you shouldn't resort to it if you have a good clean shot like the one we looked, but when there's really nothing to track and every bit helps, such techniques can come in handy. Moving the pattern away and continuing the tracking, we can see that it's possible to move the point beyond the frame. If you enable the option that the tracker exists not only within the frame, but also beyond it, the purple tracking area continues and we can keep tracking. Why is this bad? Because the closer you get to the edge of the frame, the more pronounced lens distortion becomes. Naturally, the tracker, like that hill we initially tracked, isn't actually located here but somewhere closer to the center. It all depends on the specific lens, but with such distortion, this isn't accurate data. However, if that's all you've got, at least it's something you can work with. Why is this good? Because if you have nothing else, then at least it's something. Well, yes, of course, we can immediately see that this isn't the best option, but sometimes things like this really do save the shot. So this is exactly the parameter that allows the tracker to be considered even outside the frame. The always option means the tracker is always taken into account regardless of its position, and inside field of view only is almost the same as inside the frame, but it takes into account the known lens distortions. If we slightly distort the lens and enable the field of view display, we'll see that the inside field of view area is what falls within the camera's viewing angle, taking lens distortion into account, while inside frame refers to the geometric boundaries of the actual image frame. And yes, I mentioned that this block doesn't affect 2D tracking, but in fact, with the always option enabled, you can track beyond the frame boundaries. However, this primarily affects the calculation, whether or not the point will be considered once it goes outside the frame. Next is the point weight option. Weight works the same way as with the camera. If it's a reliable, well-tracked point, one you're really confident in, you can leave its weight at the default value of 1. If the point is like the one we have here, we can see it's starting to drift. We can acknowledge that yes, it's a tracker, but not a very reliable one, and lower its weight. For example, set it to 0.5 or less, depending on how bad it is. Or conversely, if the tracker stands out positively in terms of quality compared to the others, you can increase the weight 1.5, 2, 10, and so on. You can also let the program determine how reliable the tracker is. In this case, when solving the camera, the solver will decide on its own how much it trusts this point. Alternatively, you can enable dynamic point weighting. This means the weight will change depending on the tracking quality on each frame. In the first frames, there are no major issues with the tracker. Problems start to appear when it begins to move off screen. This could be due to the tracker going outside the frame or other interference that makes it less reliable in those frames. However, we may not want to interrupt the track because even this data could still be useful. In such cases, we can specify the range where the tracker should be trusted more and where it should be trusted less. For that, we use the deviation browser. In it, we enable show point weight curves, either for all points or just for the selected one. Probably makes more sense to do it for the selected one. And now on the graph, a yellow line appears. This is the point weight over the course of the shot. The Y value can vary depending on the shot's error, but that shouldn't be your focus. For example, the current error might still be left over from our previous auto track, where the maximum reached 353. So 0 is always at the bottom, and the top depends on the error value. You shouldn't directly correlate this with the point's weight. You can move the current timeline position either directly here, or, if it's more convenient, by holding Control and the middle mouse button, and dragging like this. It's not very intuitive, but it works. The same approach applies to other panels, which we'll come back to later. Also use the right mouse button to zoom in and out, and the middle button to pan, and as always, Control plus click sets a keyframe. Here, as you can see, there's no binding. You just click and say, this is where we trust this point. Here it's still good. Well, here we still trust the point. A bit further to the right. And starting from the next frame, we say that here we no longer know exactly where this tracker is. We're just assuming. So let's begin, trusting it less from this frame on. Bezier can be disabled just like with a mask. Edit, set curve to, choose linear or broken to adjust it by keyframes. Smooth means Bezier. But eyeballing it, of course, isn't ideal. And this is honestly the kind of thing that would really annoy me if there wasn't a way to set exact values. That's why for each point, we can specify not just an approximate but an exact value of the frame we're currently on, because we can adjust the weight and the actual value of the graph. It doesn't even have to be tied to a specific frame. We can place it between frames if needed. It's convenient to do this quickly by eye, but if we want to set everything precisely, we go to the Edit menu and click Edit Curve keys. And we select which parameter we want to change. If we don't want to modify something, we uncheck it. Position X in this case is not a coordinate, but the frame number, meaning along the x-axis of the timeline graph. For example, 11 means frame 11. And in value Y, we enter the weight value, say 0.5. That's how much we trust this point at that frame. So now we know that this point is located at coordinate 11 on the time axis, X, and has a value of 0.5 on the Y-axis, which is its weight. The same can be done with other keyframes. For example, set the weight to 1.0 on frame 10, so that in that frame the point is considered fully reliable. This isn't strictly necessary. It's more for those who, like me, don't like working with approximate values. Of course, in most cases, rough adjustments will do just fine, but if you want full precision and confidence, it's better to enter everything manually. In the first frame, also a value of 1. So everything we just set means that within this range we trust this feature, and after that we trust it half as much. Next up, position weight blending and timeline weight blending. Position weight blending is the automatic reduction of a point's weight based on its position in the frame. This is similar to what we just manually edited in the weight graph, but it works automatically. The closer the tracker is to the edge of the frame, the lower its weight. At the very edge, the weight is reduced by 25% on the x-axis and 25% on the y-axis. These values can be manually adjusted. This is useful in situations where you don't have accurate lens distortion data. If you have a well-calibrated lens and are using precise distortion grids, then in most cases you can leave this option disabled. But if, like in our case, the footage was shot with an anamorphic lens and distortion wasn't calculated, no grids were loaded, no calibration was done, then it makes much more sense to either avoid tracking points located close to the edges of the frame or reduce their weight as they approach the edge, because it's exactly near the edges of the frame where distortion is strongest, and such trackers become less reliable for solving the camera and point position. Timeline weight blending. This is also a reduction of weight, but relative to the beginning and end of the tracker on the timeline. Right now it's set to 10 frames, which means the weight of the point, the weight of this tracker, gradually decreases as it approaches the edges of the track. Its start and end. If I set it to, say, 5 frames, then after 5 frames from either edge of the tracker, the point will have full weight, and the closer it is to the edge, the lower the weight. Right here, the tracker already has full weight, as much as we've specified. And closer to the edge, its weight becomes lower. What is this used for? The appearance of a new track on the timeline as the shot progresses is always new input data for the program. Imagine, the shot is playing, the camera is being solved, everything is stable, and suddenly a new tracker appears. For the solver, this is new information, and it makes adjustments based on that tracker. Depending on how well behaved the shot is and how stable the scene is, the moment a tracker appears or disappears can cause a camera jump. We may have been tracking the same points, everything going smoothly, and suddenly one tracker disappears, which means the information about the area it was responsible for also disappears. The solver then continues building the camera movement without that point, and the camera movement changes. That's how jumps occur. To smooth out such jumps, if you notice they happen specifically when a tracker appears or disappears, you can use timeline weight blending. So you identify which tracker might be causing the jump, you look at where the tracker appears or disappears, and apply timeline weight blending to that specific tracker. It will then gradually fade in or out, and the camera movement will become smoother without jerks. And how many frames you set it for depends on the camera movement, the nature of the jump, and the scene overall. Alright, and we're not touching the depth of the mocap here. I think I'll leave this option enabled. So to finish tracking this shot, we need to add a few more trackers, more points. To solve the camera, there must be a section where at least 6 reliable trackers are consistently visible. In some areas, 4 may be enough if they're high quality, but for calculating root frames, you'll need more. By the way, the root frames have already been automatically set. Those are the frames the program relies on when calculating movement. I already mentioned them in the first lesson block in the point group settings. The program automatically determines where the motion is most stable and where we have good tracks, and places the root frames accordingly. So, to calculate everything properly, we need to add more trackers. And to better understand in which frames we already have enough and where we still need more, we can open the timeline panel. Config. Add horizontal panel. Timeline editor. And here in the timeline we can immediately see where we have enough trackers and where we don't. As for navigating this panel, you can move around using the middle mouse button, and if you hold Control while using the middle button, it scrolls along the timeline. Right-click to zoom in and out along the time axis. Left-click is used for selection. It's also very convenient to use the timeline to track where your keyframes are, where the area is just tracked, and where a track has become outdated and needs attention. In such cases, you either need to retract the section or manually confirm to the program that the track is still reliable. We've already touched on tracker status. For example, a light gray or light purple area on the timeline indicates a section with outdated status. This happens when you place a keyframe inside an already tracked section. The program assumes you've made changes, so it needs to recalculate the segment forward from that keyframe. Until you do that, the track is considered outdated. I don't exactly remember what we did here, but I know the result looks good, and I don't want to retract this section. To change the tracker's status on a specific fragment, hold Alt and select the desired section of the timeline. If you notice that the status between two keyframes is shown as splined, it means the program treats that section as an interpolation between keyframes, not as actually tracked. Such a segment won't be considered reliable during the solve. So we select the section we want, for example, those two frames currently not marked as tracked, and go to Edit, Set Curve Segments to Tracked. This explicitly tells the program that this segment is valid and doesn't require retracking. So the timeline is a convenient tool for analysis. For example, if you notice a sudden camera jump, you can immediately check, here's where the jump happens, and then trace which trackers start or end in that section. You can also delete any fragment of a track. Just hold Alt and drag with the left mouse button to select the desired segment, then choose Delete Curve Segments. The right-hand vertical bar on the timeline indicates that there are not enough trackers in that frame, for example only 3, which is less than the minimum required for accurate camera solving. You can split a single tracker into 2, especially if it was originally tracked with an interruption. But later, during the camera solve, it turns out that this affects stability and interferes with the solution. Even though logically it might seem correct to keep it as 1, the solver doesn't always handle such tracks well. In that case, select the segment you want to separate and go to Edit, Split Curves. Now these are two separate trackers. The second one automatically gets a split suffix in its name. This allows for experimentation. You can disable one of them, compare results, and figure out exactly where the issue arises. It's all part of debugging your tracking. If needed, you can merge the trackers back together. Select both, then go to Edit and Merge Curves. So let's add a few more trackers and calculate the camera. Here, for example, you can clearly see that at the beginning we have enough trackers, at the end as well, but in the middle there's a gap. That's exactly where we should place additional points. Let's take a look at what we can lock onto. For example, this structure right here. It's barely occluded and clearly visible in the frame. Hold Control to place a tracker and start tracking. I step back to the frame where the tracker isn't yet occluded by the pole. Slightly shift the pattern area. I press End. This stops the track at this frame. I check whether tracking can be continued further. Overall, I can. The same tracker is selected. I click with the left mouse button and it appears. I move the pattern now to the right side. With page up and page down, I switch between this frame and the last frame of the previous tracker segment to check whether I'm in the same place. I adjust the pattern's position using the numpad keys. They allow for precise horizontal and vertical shifts of the tracker. I nudge the tracker into the correct position and continue tracking. I nudge the pattern again when it overlaps with the text. And I stop the tracker. Then I go back to the start. I set the direction to backward only. I want to track backwards. I uncheck endpoint. A purple area appears. The light color means the tracker is active, but this part hasn't been tracked yet. I step back, track frame by frame, and close the track. We can add a few more trackers. For example, let's track the spot on the pole. Shift the pattern so it doesn't overlap with the snow area, which might cause parallax, then track forward a few frames first. Track until the tracker remains stable, then return to the starting point. Change the tracking direction, open it backward, and hit track. Slightly increase the pattern search area. The pole shifts fairly quickly in the frame. Stop. Let's go back and see exactly where things went wrong. One more frame might still be trackable. Let's try calibrating the marker. This will reset the pattern's scale and rotation. Then we track one more frame backward. Endpoint, that's it. We've closed the tracker. Let's add a tracker somewhere in the distance. We need points both in the foreground and the background. Let's see what we can lock onto so it stays visible in the frame for a while. For example, this treetop. There are some minor jumps. Ideally, it's best to avoid those. So what can we do? We can recalibrate the pattern and slightly expand its area so it locks on more reliably, especially now that the pipe that could have thrown off the track has already passed and we can safely continue tracking. Much better. Of course, this still needs to be finalized. Let's try to solve it. Let's see what we get. Calc from all stretch. Here's the resulting camera movement. It's definitely much cleaner than the auto track. If you remember, that one was much more jittery. Now the trajectory is almost smooth. However, judging by this section, we should probably add a few more trackers. The motion in the shot looks consistent, but the reconstruction doesn't reflect that for some reason. This is where analysis comes in. Comparing what we see in the footage with what we're getting in 3D, only we can judge how plausible it looks. Let's apply the result. Click Use Result. Let's go to lineup controls and take a look at what we've got. At this stage, given the knowledge and tools we've covered so far, this is a perfectly acceptable result. Of course, there's still plenty of room for improvement, refining distortion, adjusting scale, tweaking weights, and adding more trackers. But even now, we've achieved a fairly clean and stable reconstruction. What's important is that each tracker was placed manually. We know exactly where they're reliable and where they're not, and we've preemptively reduced their weight where necessary. As a result, in the 3D view, we can see that the trackers sit precisely in place, especially near the center of the frame, in the crosshair. As expected, slight deviations appear closer to the edges. They will indeed drift slightly closer to the edges of the frame. That's a normal occurrence due to lens distortion. But there's nothing critical about it, and we'll deal with that later. What's important is that even now, we can clearly see we're getting much more accurate positional information. For example, the sign, even when it's partially off screen, still has its 3D point roughly where it should be. That's a good indicator that the tracking is functioning correctly. That's everything I wanted to cover in this section. See you next time.